Okie doke. Now we know some stuff about natural logs and exponentials. Let's talk about logarithmic differentiation. Logarithmic differentiation happens when you have something, so this logarithmic differentiation, if you have something like crazy that you're trying to take the derivative of. So if you have something like f of x is equal to x squared plus 1 in parentheses times e to the x over x squared plus 4. Now, if I were to try to just take the derivative of this, I'd have to use the quotient rule and the within the product rule, within the, right? So, I forgot my to the fourth. That makes it even crazier, right? So throw a little chain rule in there with it. So we're not going to do that. We now know about logarithms, so we can do what's called logarithmic differentiation. And as long as you do the same thing to one side as you do to the other, then you're legit. So I'm going to take the natural log of both sides. So the natural log of f of x is equal to the natural log here of x squared plus 1 to the fourth e to the x over x squared plus 4. Now we're going to use our algebra skills in order to break down this crazy part over here with our logarithmic properties. So let's do it right now. I'm going to scoot it up a little bit. So this natural log of f of x just hangs out because there's nothing I can really do there. I'm going to do all this at one time, right? This is the quotient rule, so I know that's going to be minus. This is product rule up here, so I know that's going to be a plus. And I'm going to take this 4 and put it in front, all right? So what I actually have is 4 natural logs here of x squared plus 1 plus the natural log of e to the x minus the natural log of x squared plus 4. Right, so that's just our algebra that we can use to pull that off. Now I have something that's going to be easier to work with. Once you have this all laid out like this, now I can take the derivative of the whole thing, and whenever I'm going to put this in front, so d over dx of this whole thing, I'm taking this whole derivative. Now, remember, whenever you have a natural log, you go 1 over the inside times the derivative of that. So this will be f prime of x over f of x, because it's 1 over f of x times the derivative of this function, which is f prime. And see how that comes? Okay, now I take these derivatives. I've got 4 over this x squared plus 1 again times the derivative of that, which would be a 2x plus, and if I have this natural log in e, remember natural log and e are inverses of each other, so what I'm actually just taking the derivative of here is this x, and that's how we get just this 1 minus, whenever I take this derivative, I've got 1 over x squared plus 4 and then times that 2x. I only have a 4 in the numerator here because of that coefficient, right? Okay, now clean it up. If I'm looking at this, I am also going to take, with this f of x, my goal is to get the derivative. So I'm going to multiply this side by f of x, and I'm going to multiply this side by f of x. Oops, let me squeeze this in a little bit. And we know f of x is my original function. Okay, so check out, I'm going to put it in front, so check out how all this plays out. I've got f prime of x equals my original function, which is x squared plus 1 to the fourth e to the x over x squared plus 4 times, I'm going to scoot it up a little bit now that we've seen that, this 8x over x squared plus 1 minus 2x over x squared plus 4 plus 1 in the back. And when you have logarithmic differentiation, unless it's something that's super easy to put together as rational down here, then you just leave it. So your answer for logarithmic differentiation a lot of time is wonky donkey there. All right? Okay. You guys go rock the socks off of this stuff. I know you can do it.